So module 2, we have a gaseous suppression system, right? So we have to discuss, uh, sorry, module 2 is for the special extinguishing system, where we have gaseous suppression system, CO2 suppression system, dry chemical extinguishing system, wet chemical extinguishing system, and we have CO2 extinguishing system and water mist system. So firstly, we'll start from the beginning phase, right? So halon, there was before 1990s, we have halon system, which is not environmental friendly, means which is affecting our, ozone layer, and there is lots of the environmental issues. So they moved on to the more clean product, which is halocarbon and inert gases. And sometime we'll discuss regarding water mist system also in a while. But mainly we are going to start with section 1 in module 2. We have the clean agent fire extinguishing system, uh, and this system shall be installed as per NFPA 2001, which is standard on clean agent fire extinguishing system 2018, right, the latest one. In this system, we'll discuss in a while. We have a cylinder with a control valve at the head of the cylinder, electrical valve actuator, the piping, and those piping going to the different nozzles. So this system will be activated by a detection. There is a detector placed in the same area. Those detector, the smoke detector, will detect the fire, and they will give signal to the release panel, the control panel, and those control panel will give signal to the electrical actuator here to open the valve, and then the gases extinguishing system will be discharged and extinguish the fire. This is the working principle, and we'll discuss in detail. Just wait a moment. Now, so this system is not a standalone system, right? NFPA 2001 is not a standalone system, because we have to integrate those systems with NFPA 72 for activation of the suppression system, for detection of the fire inside those areas, and for evacuation system, right? The alarm, the stove sound, and all we can get one. You have to install those system based on NFPA 70, right? This is installed mechanical. Sorry, this is for National Electrical Code. So all the wirings, fitting, all the wiring conduit, the conductor should be based on the NFPA 70. Now those requirement comes from the life safety code, right? The life safety code will tell you where to install clean agent suppression system. So we have to refer to different model come together. So no standard is standalone. We have to uh, combine all those together to come to a final safety point. We have now basic definition, right? We have halocarbon agent, right? So normally the this halocarbon is a clean agent, right? So the definition is that this agent doesn't contain the primary component of halocarbon are maybe one or more organic compound. It might be fluorine, chlorine, bromine, or iodine. So these are some of halocarbon agents. So what are the inert gas agent, right? So the agent contains as primary component one or more of gases like helium, neon, argon, or nitrogen. As a secondary comment. So in the clean agent system, we have two kind of the product. The first one is the halocarbon agent, and then we have the inert gas agent. We'll discuss that one by one. As for 3.3.20 of 2001, we have the lowest observable adverse effect level. We call it LOAEL, right? So what is this exactly? This is the lowest concentration of the fluid inside inside a closed room, right? Which gives some adverse psychological or toxicological effect. So at the minimum percentage of this gas inside the building into the atmosphere, right? What is those percentage? If those percentage goes beyond above than that, then there might be some effect. So we'll discuss that one also. And then we have the no observed adverse effect level, NOAE. So it is the highest concentration of the product at which we don't have any toxicological or psychological effect for the occupant into the building. So where are the application? What are the application for the clean agent suppression system? The meaning of the clean agent suppression system is that, once those agent discharges, it will not leave anything back. When you need the clean agent system, right, we need full homogeneous three-dimensional effect. There will be a complete flooding system, right? So we have three-dimensional effect. Once it discharges into the room, suppose this is your room and the gas system is discharged, right, in case of the fire, it will extinguish the fire and there will be no residue, there will be no residual product. Like if you are using fire extinguisher, AP multi-purpose fire extinguishers, to fighting the fire, there must be powder lying around those areas after the fire. But with the clean agent system, once those system discharges, it will not leave any kind of any kind of the remaining items. Everything will be the gaseous product will all be gone soon after the fire. And it have no electrical conductivity, direct or indirect penetration into cabinet or installation. You can install this system inside a cabinet. We call it a local application system, or we can install a total flooding system. We'll discuss that in a while. When we need this kind of a system, right? We need in a shielded object, hardly accessible, deep-seated or concealed fire, high ceiling sensitive equipment where water could cause same damage like fire. So in area where we have damage from the water is similar to the fire. Let's say there is there is an electrical equipment, costly data center, right? So those data center, even there is a fire, we need to protect those data center, right? The electronic equipments and the computer equipment at all. So if there is a fire, we discharge the water, everything will be destroyed along with the fire. The fire will be gone, but the cost of the damage of those projects is still way much more than that. So we need clean agent system in those area, to control the fire. It will not leave any residuals. So what are the applications for the clean agent system? Right, so the application is wide. We can use in the IT areas, switch gear room, communication room, control room, cable tunnels, data center, archives, right, electric cabinet, and many more. We can use that one in the libraries or the old heritage building or museum, right? We don't want to lose our product, our building inside, our building equipment. But if there is an actual fire, we need to protect that one. So we cannot protect that with the water, because water again damage those products. So we need clean agent system. So sometimes clean agent system is the alternative for free action system. The double interlock free action system discussed in the beginning yesterday into the sprinkler system class, right? We need activation from the smoke detector, and we need the activation of the sprinkler system. All together will combine, and then only there will be the fire. So we have some common agent, right? We have SFC 227EA. We call it this is an NFPA designation in 2001 standard, right? The common trade name will be FM200 or FE 227. HFC stands for hydrofluorocarbon. So these products are, uh, not so much, damaging our environmental, our space, our area where we are living. Like this is not having more ozone depletion potential or not having more global warming potentials. So we can use that one. So most common product we have HFC 227EA and FK512. We call it Novik 1230. FM200 and Novik 1230. And then we have the inergen, argonite, argon, and nitrogen. We are not going to discuss that one, but we are mainly going to focus on FM200 and Novik 1230. You guys are there, right?
Professor Ravi, you are with you.
Okay.
Yes.
Now, out of those product, like we have Novec 1230 or HFC 227EA, FM200 and all. We have comparison sheet, right? So the concentration for the Novec we have, what is the concentration that, let's say your room, we have to calculate the room which should be protected by the agent in volume. If your room is 1000 square feet, right? So we need the weight of those product, the foam system, sorry, the gaseous clean agent system, right? 4.5% minimum of the volume. So if your room volume is 1000 square feet, multiply that one by 4.5%, right? So if you multiply the 4.5%, we need that much quantity of weight minimum into that room. So this is the concentration. Novec need 4.5% to 6% of the room volume, and HFC 227EA need minimum 7 to 9% of the room volume. The first column about the concentration. If you can see at the bottom, we have CO2 system, right? CO2 is also a kind of the gaseous suppression system, but this is not as a clean agent. I'm just giving for the comparison. The CO2 is not clean agent system, but again, you can see in many locations the CO2 system. Now you can see the concentration of the CO2 is 34 to 75%. It means 34% to 75% of the room volume we need the CO2 system. So the problem with the CO2 system is that when this CO2 system discharges into the room in case of the fire, it will replace the oxygen, right? It will replace the oxygen and all. So the room become full with the CO2. So now no one can survive in those conditions. This is the reason why the building code and all kind of the safety bulletins that CO2 is not allowed for manned location. Means in some area where there are presence of the persons, we cannot use that one. So only we can use this kind of the things in place where there is no one, like switch gear room or something like that, where we don't have anyone present inside the building. And if someone is going inside the building for any kind of the maintenance or any kind of the work, he should close the CO2 valve from some of the means of arrangement is there before going inside. And then we have the sustainability, right? The atmospheric lifetime for the Novec 1230 is 0.014 years into the atmosphere, which is like 9 days, right? And for the SFC 227EA, we have 33 years. The ODP for the Novec and Globe for the Novec and the ODP for Novec is the 0, and for SFC 227E is also 0. So what is the ODP? Ozone depletion potential. You guys maybe know some of the basic environmental studies, guys. Yes, my friend.
This gas maybe affect the ozone layer.
Yeah, exactly. This gas is affecting our ozone layer most of the time. So if you can see the live ODP layer of all the clean agent is 0. Either Novec or SFC or SFC 227EA or SFC 2030. We have the 0 ODP for all. And the global warming potential we have at the bottom. That is the other case. This is the reason why. Yeah.
Is it good for? Is it not harm the environment?
Yeah, it will not harm the environment. If you want some gas which is not harming environment in any way, the best one we have Novec 1230, and after that we can go with the FM200. FM200 came first, and after some years, the new company made the Novec 1230. That is more cleaner than the FM200 in terms of the global warming potential and the ODP. Other function is the same. These two gases are the having clean agent gas, but the Novec is the more better than FM200, a little bit costly also at the same time. And then we have the types of system, right? Different types of system we have for the gaseous suppression system. We have engineer system, we have local application system, we have pre-engineer system, we have the total flushing system. In the local application system, right, we have if you can see at this arrangement, this is a cabinet. We supply the gas directly inside the cabinet. So if there is a fire inside the cabinet, this should be extinguished by this small arrangement. So it is only protecting the local application. It's directly into the data room, data center, some small cabinet or some small disk. This one is the example. You can see at the bottom two are example for the local application system. The top one is the total flooding system. The meaning of the total flooding system is that, in total flooding system, a system that consists of a supply distribution network, right? So we have so many number of cylinders, right, connected to a common header, and those headers are going directly to the room. So the flooded system is the complete room. The complete room inside those area, in case of the fire, all the system will be discharged, and it will flood the room from that gas and extinguish the fire. This should be done in the hydraulic calculation software to install at the site. Now we have three engineered systems. Sometimes we have predetermined flow rate, nozzle pressure, and quantities of agent. And this system have already listed the specific pipe size, maximum and minimum pipe length, flexible hose, number of fittings, types of nose exercised by testing laboratories, right? So these are the protected in specifically limited to type and size by a testing laboratory. So the testing company who test the pre-engineered system for a specific requirement, this will be applied for that only. Means it is applying for the specific requirement. Most of the cases we are using the total flooding system because if your project size is big, we have to go with the calculation of those system. Like hydraulically, we have to control the system. And here we have a component of the system, right? We have a different component of the system. We can see we have the storage tanks, right? The agent storage tanks. We have the control panel, notification appliance. In case of the fire, it will allow person to evacuate the building. There are the fire detectors in the room, right? So those fire detectors will give the signal to the control panel in case of the fire. We have the fire, and those control panel will give signal to this control head. So this control head will be open and the agent will be discharged to this room. Now while agent discharge, with agent, the executing agent discharges into the room, at that time the peak pressure into the enclosure, right? If something in discharging with some pressure, now you must know that the different pressure rating us for this clean agent system, starting from 24 bar to all the way to the higher ratings based on the different requirement. With this system discharge into the building, right, it is giving a pressure up to from 2 pascal to 1200 pascal into the room within fractional of second. So if your room is not designed based on those kind of the shock to withstand those kind of the shock, maybe the physical integrity of those structure will be damaged. So we need the pressure venting device. So this pressure venting, if the pressure in the room goes higher, it will open for some time and discharge some amount of the pressure, and it will close automatically. And we have the HVAC, we need the shutdown of the connection, right? So the room which is protected by FM200 or NOVX system, right? Before the discharge of the system, all the door, window, air conditioning unit, right? Doors, everything will be closed. Otherwise, the concentration will not receive the full and fire will continue. So before discharging of the agent, in case of the fire, all those systems should be closed, and then it will be discharged.
So, Mr. Rabi, just what you just explained
Yeah,
is we will shut down the AC and all dampers and whatever is there.
yeah.
And at the same time, we will open a discharge or what you said for the not to over pressurize the enclosure is what?
No, that will only open if the pressure inside the room goes more than the design limit. If more than, it will open for some pressure limit only. If the pressure goes more than that, they will open and it will close within second. just to relieve the pressure. It will not open
Okay.
instantly.
So it is a standalone. It is a standalone device that it will sense the pressure open and close by itself, or what?
Yeah, it is just like a pressure relief system, like pressure relief valve you can see in our piping. This is a pressure relief venting, which will open at some pressure and then it will close.
Okay, and it will be installed in the structure itself.
Yeah, it will be installed within the room only and should be allowed for the venting. Otherwise, the peak pressure will damage the system.
Yeah, I remember I was witnessing before a couple of years a CO2 system full discharge test.
Okay.
And as you just mentioned, the quantity of CO2 usually it need to be high concentration inside the room.
Yeah, around 34%.
Exactly. So after the system the discharge, uh, there was a really high pressure inside the building. So all the doors of that enclosure was like the latches of the door just bent and break, and all the door opened because of the
Because
high pressure
yeah,
inside.
yeah, exactly. Because those who are installing the system, they are not giving more emphasis on. It's now matter of the fire protection contractor and the maximum of the civil construction team. Those person don't know what is happening with the fire protection system, its pressure and all. They have to work together to
Mm.
get the approval. They are not giving more importance to the structural ability of the structure in case of the release of the fire system and pressure pickup inside the closures. Should be work together, to get some final values.
Yeah, but if the system is being installed on some existing structure, then the part of the fire protection system installation, they have to install this pressure relief devices.
Yeah, enclosure pressure rating. Yes, they have to use that one. They have to
Mhm.
use this one. And there is some other kind of the equipment that we'll discuss. The door fan test and all. We'll discuss that in a while.
Okay.
Then we have the head, right? This is some basic component of the sprinkler system. Sorry, for the FM200 system, right? We have AGEN cylinder, the liquid level indicator. We can see what is the level of the liquid inside the containers. And the pressure gauge, we can see the pressure inside the system, right? We have the electric motor head. This normally gets signal from the control panel to release the valve and discharge the water, discharge the gaseous suppression system for in case of the fire. Either you can also install this manually. You can see there is a pull station, right? There is a corner pulley and cable operated conveyor. We just pull it and the system will discharge. This is the other arrangement. Now we'll be going for different definition. Control panel, yes, control panel is the brain of this system. It will receive signal from the detector and allow the electronic control head to open and release the suppression system to extinguish the fire. We have a release device also, right? If you can release, it is attached to the cylinder, right? And it is activated by the control panel. And we have the abort switch, right? Suppose if there is a fire and there is fire and you are hearing some sound that it is going to be activated, but still there are someone inside the building and he want to go outside of the building. He want to evacuate the building. You can just abort those functions by just press and hold. By the pressing and holding this system, you can abort you can delay the discharge of the system for some second, not for long time. So this solution is there with the gases suppression system. And then we have the nozzle size. We have different. We have two different types of the nozzles, right? We have 360 degrees nozzles and we have 180-degree nozzles. Normally, 180-degree nozzles installed at the center of the building, or the enclosure in between in the middle, and the 180-degree nozzles we install at the wall, in the wall side. This is based on the arrangement of the building and the design criteria we can install. We have switches, pressure switch, which will change the high and low pressure the the system. The pressure goes below 21 bar, it will give some sound to the control panel that the pressure is going below. And if the pressure is going high also, it will give us some signal. So we have to supervise the pressure inside the cylinder.
So this, Mr. Ravi, this pressure switch will be installed on the cylinder itself, right?
Yeah, it will be installed on the cylinder only. It will measure the pressure differential in the cylinder along with the control head.
Uh-huh.
And then we have reserve switch transfer, right? So normally there are a main supply and there are a reserve supply, right? So sometime one system discharge and you went for the feeding the system, or if you want to maintain one system, if you want to do maintenance, you can just transfer the line to the other switch, other cylinder. So it is like a standalone support. One will be doing maintenance and the other will be in the service. We cannot take out all these two cylinders together. So we have a main and we have a service one. Now we came to clean engine system design. This is just basic overview for the design. For designing the system, uh, we have to know the hazard analysis, room integrity, the one you discussed that the CO2 system came and it's destroyed the room. Of course, room integrity have to be have to design very carefully. Then we have to go for the design concentration, and then finally we have to go for the system limitations. What are those system requirements at all? So the first step for first exercise in planning a clean existing system is to hazard survey. Go to the site, see what need to be protected and what are the all those criteria. And those information you can get from the survey. You should include risk assessment, environmental condition, personal consideration, system operation, normal condition, and after the discharge access and construction limitations. What is the volume of the room? What is the special requirement? Everything you have to go to the site before designing your system, right? If you are going to the site, you have to look for the volume. What is the volume of the system? Where should I keep the cylinders, and what are the door requirement, what is the window, how we are going to close, how we are going to open that, what we need to be protected. So based on that, we have to select those. What is the requirement for the protection, class A or class B or class C?
Mr. Rafi, risk assessment, right?
Yeah, risk assessment, we might get the risk assessment study also.
Okay.
Just now who is Mr. Hajiri, right? Risk assessment.
Sorry?
You just now spoke regarding risk assessment, right?
Yes, risk assessment, yes.
Yeah, this is the second time you ask this regarding risk assessment. Look like you are more involved in those risk assessment and safety studies. Is it?
What?
You are more your more job are related to the risk assessment and the safety studies, right? So you are
Yes,
asking this kind.
because the risk assessment very important for the
Yeah,
designer or for the human. Risk assessment very important.
yeah, exactly.
I am Muhammad Jabir, not Muhammad Al-Hajri.
Okay, Muhammad J. Asiri, right?
Yes, yes.
I think already it's 6:40 now, and as I promised that I'll just stop at the prayer time and I'll start tomorrow. So tomorrow might be we will finish module 2 completely, and we have to cover 3 different systems. So we might go up to 7:30 for tomorrow. And as I said in the beginning of this class, we have continuous class this week for 5 days, and then we have class on Sunday. Monday we have exam, and Tuesday and Wednesday I will try to go with live session into the lab. I will try to record the video based on the best feasible time. Your exam will be on Monday, available from Monday to all the week. You have to complete.
Available for 1 week or 1 day?
That will give access for 2 or 3 days. Don't worry. You have to just finish within those time specifications. That's it. Maybe it will be there for 2 days.